we're competing in a 4-year competition sponsored by General Motors, Argonne National Labs, and the Department of Energy to redesign a Chevy Camaro and make it a hybrid electric vehicle. We're competing with 15 other teams across the nation. All of the work is student designed and student done. So the first year and a half we're spent working on the design and simulating the car. Ever since year 2, we've been working on getting our design into the car, which includes 2 electric motors and a battery pack, so we can operate in 4 different modes.
We got the car with the V6 engine in it, and to transfer it into what it is now, year 1 was a bunch of planning and design work to figuring out where all the components were going to go into the vehicle. So there's coding that goes involved into it, mechanical, electrical, computer engineering all went into making the vehicle as you see it today. Out here today we are testing some events that we'll be competing in at competition, specifically 0 to 60, skid pad, and 50 to 70. 0 to 60 is just measuring the performance of the vehicle. We have a target time of quicker than 5.7 seconds, and what we're able to do with the results we have today is figure out where we need to add power, if there's shifts that are taking too long. So that's what we'll use those results for. The skid pad is more about handling of the vehicle, so seeing if we need to change the suspension a little bit to balance it out, because we did add quite a bit of weight to the vehicle. So figuring out how that weight needs to be redistributed or counteracted with the suspension is key in the skid pad event.
My team creates simulations on computers and a lot of code that goes together to simulate the car in a virtual and digital environment so that we can actually create the control code that makes the car work. The only thing that's stock that's still in the car is the transmission. So we had to incorporate all of these non-Chevy components into a Chevrolet Camaro. So first it's the mechanical hurdle, and then it's creating from scratch a control strategy, which is pretty much like the brain for the car, creating some kind of control strategy that the car can follow from nothing, from one blank file. So we actually tested 2 different control strategies in the car today on a 0 to 60 test and a ride and handling test, and got some good data with that. So we're going to use that to incorporate it into our current control strategy and make it better. So from here on out we do exactly what we did today over and over again. We come out next week and then the week after, and then we keep just making improvements to the control strategy and the mechanical things in the car. So it's all optimization from here on out.